Section 5.5, number 23, asks us to solve this equation. So this is quadratic, and we have a method for solving these. We've got everything on one side, in this case the left side, and 0 on the other side. And what we're going to do is we're going to factor. So when we factor this trinomial here, I see nothing common all the way through. So let's write our two sets of parentheses, anticipating we can do this. Don't forget to equal to 0. Now for the s squared, just use an s and an s. And for this 35 here, what do we want to use? The factors of 35 are 35 and 1. Not going to get a 12 out of that. Or 7 and 5. 7 and 5, we can get a 12 out of that. So let's use a 7 and a 5. The 35 is positive. So these two numbers have the same sign, which is that positive 12, positive right there. So we're going to write a plus 7 plus 5, so we've got it factored. Now, by the zero factor property, we'll do this one all the way out. Here's what could happen. S plus 7 could be 0, or S plus 5 could be 0. And then solving each one of these smaller linear equations, we'll subtract 7, we'll get S equals negative 7. We'll subtract 5, and we'll conclude that our solutions are negative 7 and negative 5. Now, we could actually see that from this right up here, right? From what we've been doing in our previous problems is we change the sign of the constant, divide by the coefficient, which in this case is just 1. Now, let's solve this equation here, number 25. So, nothing common all the way through, so let's factor. Here's our two sets of parentheses. How about a t and a t? Now, the factors of 21, that'll give us a 22. Well, 7 and 3 is not going to work. 7 and 3, I can't get a 22 out of that. But 21 and 1, I think that's going to do it. So let's write a 21 and a 1. And the 21 is positive. So these two numbers have the same sign, which is that middle minus sign. So we'll write t minus 21, t minus 1, and then we'll conclude that t is equal to, now here's how we do this, remember, change the sign of the constant, divide by the coefficient. So positive 21 over 1, so it's just positive 21. And from this factor here, we just get a 1. There's our two solutions to this quadratic. Now in this problem, it's still a quadratic, but what we're going to have to do is, our method of solving quadratics is to get everything on one side, all terms on one side, 0 on the other. So let's do that here. Let's subtract 8 and add 2r. I'm going to get at things on the left side because this r squared is already positive. So here's what we'll have. We'll have r squared, and we're going to add that 2r plus 2r, then we're going to subtract the 8. That'll give us 0. Let's factor. So we'll get an r and an r, and the factors of 8, that'll give us a 2. Are going to be a 4 and a 2. And since the 8 is negative, these two numbers have opposite signs. And I'll put that middle plus sign with the bigger of the two products. So I'm going to put this as plus 4 minus 2. And then I'll read off my solution as negative 4 from this term, change the sign, and positive 2 from this term, change the sign. There's our two solutions to this quadratic equation. Now, problem number 29 is pretty much the same as number 27. Let's solve this by getting all the terms on the left side, and I'm choosing the left side because I've got the quadratic term, the squared term is already positive. So here's what we'll have. We'll have x squared. Now let's subtract the 4x, right? Plus 4x, so we'll subtract 4x from both sides. And then we've got a plus 32, so let's subtract it. Minus 32 equals 0. Now we'll factor. Don't forget to equal 0. How about x and x? Now, the factors of 32, that'll give us a 4. 32 and 1? No. 16 and 2? No. How about 8 and 4? I think that's going to work. 8 and 4, and I want a minus 8 and a plus 4, from which we'll get x as 8 and negative 4. Our two solutions to this quadratic equation.